So if you want to know more what this stuff is all about, stay tuned. If you've been following me on Twitter, then you know that I've been working on this 3D printed set of keycaps for the MicroPET, and now let me show how it all came to be. Okay, here is the case that I built for the MicroPET, and I think I've shown it in the previous time where I cut out the holes that are needed for the connectors, and now I have designed and printed some more parts to hold the board in place, like this this kind of holder structure here that is connected to the case with these screws screwed to the case. This screw here in the edge is directly from the board to the case, and here those screws keep the board on the connector. Also, I've added a kind of mask to close the holes that have been cut and are not necessary anymore. Similar to this one, it's a separate part. And I think I've already shown the holders for the keyboard. So now if we put in the keyboard like this, slide it in here, click it on, and then make sure the cable is all in, and then we add the case. And there you have it, the first MicroPET with a completed case. Nice. As there also is the option to use real Commodore 64 keyboard in the ROM, I've designed some other supports here, so you can just use the Commodore 64 keyboard, slide it in like this. And then you can use it, of course, with an unmodified top case, which I don't have here right now. As you can see, it still kind of fits. Yeah. I think I've already shown you this second keyboard I made, also from Tekelec, using a standard keycaps set that I bought, and I managed to get it kind of done with only 3 keys that have the wrong inclination of that. Actually, I wanted to buy one of those that have the same inclination of the key for all rows, but I obviously bought the wrong one. So, but it's just Shift Lock Return and the 4 key that have slightly different angles. And what I also used is I've taken the PDF from Steve Gray's website and printed it on some sticky paper and put it on there on the board so you can see it. What I haven't shown you yet is that I also made some boards from the design by Steve Gray, and in this board I still have to build. And what I'm going to do is I'm going to actually 3D print the keycaps like this, as you can see here, with the characters on top, and maybe hope you can see it in the camera, and the graphic symbol on the front side, and then use that also for MX key switches. And I'm really excited that 3D printer is printing out the final design. So yeah, really looking forward to that. So if you look at the board from Steve Gray, you can see it's wiggling in here. It has slightly different dimensions. Not sure if this is the last version. I will have to talk to Steve and see if I have to print some different holders here. Also in the previous designs I have been using the blue MX switches, which I noted in the meantime quite annoyingly loud and sometimes. So this time I bought red MX switches, which are supposed to be very silent. So I hope you hear the difference on the video. Also, what is the difference is, you can see it. The blue switches I have, they have 5 pins. And when you put them onto the board, there are 2 pins that connect to the board, after electric connections, and 3 pins that do physical adjustment of the position. And you can just put it in. At least I think so. Yeah, you could just put them in, and that's it. They are fixed on the board. That's how they are supposed to work. The red one, my provider only had those with 3 pins, which is the middle pin to center the key and the 2 electrical pins. You can also put them in just like this, of course in front of the camera. But as you can see, you can slightly turn them, so it will be much more work to adjust them while soldering and not have one like this wavy line of keys coming up out there. So that's what I'm going to do next. So there is another difference between the Tekelec and the Steve Gray board, because both of them have the extra keys next to the space key. So both have them, I think, connected to the space key by default. However, there is the option to cut some wires on a board and then connect it to some other functions that you would want to do. So here you have the option to add some connectors where you can add extra lines. Actually, the board has those extra wires as well as the 5 volt for the shift lock functionality. However, what Steve found out is that in the key matrix of the Commodore PET, there actually are empty places where no keys are actually wired in the original keyboard, but they are still handled by the original key scan routine. So he has the option to put those keys into empty spaces in the key matrix, and that is actually what I'm going to do. So I will be changing my Tekelec keyboard, and instead of wiring those extra wires in here, I'm going to wire them to the rows and columns of the keyboard matrix so that they appear on the same places as the keys that Steve has done on his keyboard. So here you can see the basically finished board with the MX switches mounted on top of that, and also the first printed keycaps, 3D printed keycaps that I designed. And I used a parametric keycap generator that creates these STL files for the 3D printer, and it took me quite a while to find the right settings. But here you can see how they look like, basically exactly like the original keys from Commodore. And here you can see all of the keys of the PET keyboard have an inclination. They're not flat on top, but they are angled to the top, or here to the left, and but they all have the same angle. So and that's what I've decided to use for my keycaps as well. And it took quite a while to actually design the keys in Tinkercad. I had those keycap templates, and then I used extrusion for using the microgrammar font, which is the font that Commodore used in the original PET, and some other sources. They're all linked in the GitHub page that is being published. For the graphics characters that are on the front of the keys, and now you can see a set of those keys, a part of the set of those keys printed on my 3D printer. When you look at the details of those keycaps, you can see that using a filament printer, you can see maybe that on the bottom there is a little bit wider, and there are some supports printed here to keep the stem in the middle from keep it from breaking during the print process. You have to remove those before you put that onto the MX switch. That is, you can see this is kind of pressed flat a little bit. But this is a little bit. You have to work with the cutter to remove that to make it work. A friend of mine has printed them with a resin printer. I'm not sure if you can see it here in the camera, and also it's clear, so it's very difficult to record. But the resin printer is really much smoother, and you can see that it's really very much nicer, and you see that the supports are not pressed flat, but are really just this small as they should be. So that's very nice. On the other hand, what I hear that the resin printer is much slower than the filament printer. Actually, it took me in total over 100 hours to actually print the whole keyboard. Yeah, 100 hours of pure printing time just for the keycaps. How do you like that? So you may have noted that all the keycaps don't have a white print on them, but have extruded characters and graphic symbols on the front of the keys. So I tried various methods of coloring those, and you may see these examples here, and different types of colors, and wax crayons, wax pens, and white color. The best result so far that I got was something like this, where I used a small syringe to put in the white color, which is acrylic paint that was thinned into the extruded part, and that worked for the most of the top part, but when I tried it on the front part, just the droplets that came out of the syringe. I'm not sure if you can actually see that very well. That made the color go out of the actual extruded part, and then you can see that it's not very nice. So if you have any ideas how to color those keys, drop them in the comments below. Let me know. I'll try them out. I have some left to try out before I'm going to work on the whole keyboard. Especially, it's not just if you look at that. I tried it with the syringe here as well, and you can see it just doesn't. It only works when the extrusion is of a certain width, which is not the case for for those special keys like insert, delete, shift lock, or where else there's some more text on it, and also for the front covers. So if you have any idea how to color those keys in a way that actually works well, drop it in the comments below. So today I've shown you the MicroPET in this version with basically all new parts, with a new printed keyboard, open source keyboard, PCB, so you can really build your MicroPET out of all open source, all available new parts. So I think this is a great achievement. I hope you like it. Again, if you know some way to color those keys easily and reliably, drop it in the comments below. Yeah, the next video will be an overview video where I will be showing basically a summary of all the properties of the MicroPET. So stay tuned. Thanks for watching.